I am Professor Jayant Chopde, working in Electronics and Telecommunication Department. I would like to welcome to this lecture on signals and system. In this lecture, we are going to study the introduction to signals, introduction to systems, and the different types of the signals, and in that continuous time and the discrete time signals, and periodic and aperiodic signals. Before starting the content delivery, we will discuss what is the need to study the signals and system, or why study the signals and system, because signals and systems are the fundamental to almost all engineering domain. Second, in the development of any system, there are the different phases, and for each phase, the knowledge of the signals and system is required. The four different phases are: first one is the system modeling. This phase relates the input and output signals by mathematical equation. Example is the differential equation or the difference equation. Second phase is the system analysis. In this phase, we studies the behavior of the system for the different possible signals. Third one is the system design. In this phase, we develop the architecture for the system as well as finding the specification of the component value and their interconnection. And the last phase is the test the system, check the system and the input output signals to see that the performance is satisfactory. Now in this slide, I have mentioned some major application areas where the signals and systems is used. First one is the communication system, audio and speech processing, image and video processing, and all are the engineering domain where the knowledge of signals and system is required. Now this image shows the general structure of this communication system. Now if we have to send this message from one place to another place, then the transmitter and the receiver is required. Here the transmitter and receivers are the systems, and the message signal, transmitted signal, and here the received signals, these are the signals. Then what is the signals? Definition of the signals. Signals are defined as a function of one or more independent variable, typically carries some type of information. Is a function of one or more independent variable, carries some information, is called as the signal. Now here the independent variable can be time, spatial coordinates, or any other types of independent variable. The day-to-day life signals are music signals, speech signal, motion picture, photos, and heartbeat signal. Now I am speaking with you, this is the speech signal, and the speech signal is the function of independent variable, and that independent variable is time. And this information is speech signal is the sequence of sound, and the representation of the speech signal is like this. Here where the air pressure is the function of time. Now here I am using this microphone. Microphone is a system. Systems are used to process the signal. The input for the microphone is the speech signal, and output of this microphone is the electrical signal. This is another signal. This electrical signal is a function of time, and this representation of this electrical signal is like this. Means in case of electrical signal, the voltage or current is the function of independent variable, and that independent variable is time. The number of independent variables decide whether their signal is one dimensional or the multi-dimensional signals. Now a signal which is a function of single independent variable is called as the one-dimensional signal. A signal which is a function of two independent variable is called as the two-dimensional signal. This is the mathematical equation for the one-dimensional signal, and this equation is in terms of only one independent variable, that is t. And the examples are the speech signals and heartbeat signals. Here this image shows the one-dimensional signal, and this independent variable is t, that is single independent variable. In case of the heartbeat, the speed of the heartbeat is the function of only single independent variable, and this signal is called as the one-dimensional signal. A signal which is a function of two or more independent variable, that signal is called as the multi-dimensional signal. Now this black and white photograph is the example of two-dimensional signal. Now here the intensity or the brightness at each point of the photograph is the function of spatial coordinates, that is x and y. Means this is the function of two independent variable x and y. Hence this signal is called as the two-dimensional signal. This is the mathematical equation for the two-dimensional signal in terms of x and y. Now the example of the three-dimensional signal is the motion picture of the black and white TV. Now this is the picture, and the picture is the function of two spatial coordinates x and y, and this motion picture is the sequence of this picture, and that sequence of this picture is the function of time. Means this is the function of x, y, and t, three independent variable. Hence this signal is called as the three-dimensional signal. Then systems are used to process the signals. The definition of the system: a physical device that perform an operation on an input signals and produce the another output signals is called as the system. Now the block diagram for the system is shown here. Now here the input signal is also called as the excitation given to the system, and the output signal is called as the response obtained from the system. Now if we take the example of the amplifier, for the amplifier, input is the weak signal and output is the amplified signal. Means here the operation performed on the input signal is the amplification. The output signal yt, that equal to some operation on these input signals, and here the t denotes an operator. Examples of the systems: first example is automobile driver depresses the accelerator pedal. Now imagine you are driving a car, and if you have increased the pressure on the accelerator pedal, car is a system. What is the response or the output? The response is the speed of that car will be increased. Then second example is the general structure of this communication system. In communication system, there is transmitter and the receiver. Transmitter is system, receiver is system. Now the information signal is given to the transmitter. System process the signal, means this information signal is input and the output signal is here optical signal. It processes this information signal and output is the optical signal, and that optical signal is transmitted over this communication channel, and to the receiver input there is optical signal, and at the output of this receiver is again the information signal, because receiver is the system. Then classification of the signal based on the nature and the characteristics. Signals are classified as continuous time signals and the discrete time signals, periodic signals and aperiodic signals. Aperiodic signals is also called as non-periodic signals. Then deterministic signals and the non-deterministic signal. Non-deterministic signal is called as the random signals. Energy signals and the power signals, and even signals is called as symmetrical signals, and the odd signals is called as the asymmetrical signals. Then first type of signal is the continuous time signal. Continuous time signal exists at every instances of time over the particular time interval known as the continuous time signal. Means the signal exists at every instances of time over this particular time interval. Here this particular time interval is T1 and T2. Now here I will take one example that will clear the definition of this continuous time signal. Here the signal x of t that equal to e raised to t. Now these signals is occur over the particular time interval, exists over the particular time interval T1 and T2. Now here we will consider the T1 is minus infinity and T2 is plus infinity. Means this signal exists from minus infinity to plus infinity. We will find out the amplitude at t equal to minus infinity, T1 equal to minus infinity, x of T1 that equal to e raised to minus infinity, that is 1 upon e raised to infinity, means 1 upon infinity, 1 upon infinity, and 1 upon infinity is 0. This equal to 0. Means at t equal to minus infinity, the amplitude of the signal x of t is 0. At t equal to T2 that equal to infinity, the signal amplitude x of t that is e raised to infinity and that equal to infinity. Means when t equal to T1 that equal to minus infinity, x of t is 0, and when t equal to T2 that is infinity, x of t is infinity. Now we will sketch this signal. This is time t, independent variable, and this is the signal x of t, and at t equal to 0, this is e raised to 0, and e raised to 0 is 1, means here this amplitude is 1. At t equal to minus infinity, the amplitude becomes 0, and at t equal to infinity, this magnitude is infinity. Now this signal, continuous time signal, exists at every instances of time or the particular time interval, and this particular time interval is from minus infinity to plus infinity, and the amplitude is from 0 to infinity, means we can say that the signal is continuous in time and continuous in amplitude. Now second, if we change the time interval t1 and t2 from 0 to infinity, then we are getting the signal will exist from 0 to infinity over this particular time interval, and that time the signal is like this. This is 0 to infinity, and the amplitude is from 1 to infinity x of t. This signal is called as the continuous time signal. Second one is the discrete time signal. The signal is defined only for discrete instances of independent variable t or time, or the discrete time signal exists at the discrete instances of time. Now here, in case of continuous time signal, the independent variable is t, at the discrete signal exists at discrete instances of time. Hence, the t is uniformly divided in discrete intervals of time, and the discrete intervals of time is denoted by n. N is the integer value. N is the integer value, and it changes from minus infinity to plus infinity. Means in case of the discrete time signal, the independent variable is n, where n is, this is integer value, 0, 1, 2, 3, or minus 1, minus 2, like this. And the signal is defined only at n value. Hence, the discrete time signal is denoted by x of n. Now here for the different n, we are getting this is x0, x1, x2. This is the set of the discrete instances of time, and this is called as the sequence. This is called as the sequence. Hence, the discrete time signals is also called as the sequence. The discrete time signal is discrete in time. Discrete in time. Here, this is n, and continuous in amplitude is called as the discrete time signal. This is the second definition of the discrete time signal. Now, the discrete time signal is obtained from the continuous time signal by sampling at the uniform time interval, and that uniform time interval is denoted by t. Means x, the signal is the written as x of n, x nt, where this t equal to nt, where n is the independent variable and this t is the uniform time interval. Now, the mathematically, the discrete time signal is written as x of nt, where this t is called as the sampling period, and n is the integer ranging from minus infinity to plus infinity. Now, the CT signals are used in FM radio and conventional telephony, and the digital signals are used in digital communication and all digital systems. Now here, the digital signals is obtained from the discrete time signal. In case digital signals are the signals which are discrete in time as well as discrete in amplitude. Now here we will sketch the signal for this particular interval 0 to to discrete time signal, that will this example will clear the difference between the discrete time signal and the continuous time signal. Now here this x of t signal, that equal to e raised to minus t, the signals exist at every instances of time over this particular time interval, and this particular time interval is from 0 to 2. Now we will find out the amplitude at the different t. Now for simplicity we will consider the t, few values of t equal to zeros, t equal to 0.5, t equal to 1, 1.5, and t equal to 2. Now for t equal to 0, amplitude of the signal x of t, that equal to e raised to minus 0, that equal to 1. For t equal to 0.5, this is x of t, that equal to e raised to minus 0.5, that is 1 upon e raised to 0.5, and that value is 0.606. Then for t equal to 1, this is e raised to x of t, that equal to e raised to minus 1, and this is 0.36. Then at t equal to 1.5, this is e raised to minus 1.5, that is 0.22. And here for t equal to 2, this is e raised to minus 2, and that is 0.1353. Now we sketch this signal, this t. Now these are the amplitude for the different t. This is x of t for 0, 0.5, 1, 1.5, and 2. For 0, this amplitude is 1. For 0.5, this is 0.606. Here 0.36, 0.22, and here this 0.135. Now we will join all these points. Now this is the signal, continuous time signal, because the signal exists at every instances of time, and the interval or the particular interval for the signal is from 0 to 2, and amplitude is changing from 1 to here this is 0.1353. Then sample the same signal x of t, that equal to e raised to minus t, with sampling period t equal to 0.2. Here the sampling period is given, that is 0.2. Now we write this signal in discrete time. The discrete time signals is like this: x of nt, that equal to, substitute t equal to nt. Now here this signal is x of nt, that equal to, here substitute this instead of t, nt, e raised to minus nt. Now here what is t? T is the sampling period, and that is given x of nt, that equal to e raised to minus n into 0.2, means this is e raised to minus 0.2 into n. Now for different n, we will find out the magnitude: n equal to 0, n equal to 1, n equal to 2, n equal to 3, like this. Now for n equal to 1, 0 first, What is the magnitude x of nt? That equal to e raised to minus 0 means this is 1. For n equal to 1, for n equal to 1 here, what is the magnitude here? E raised to, this is minus 0.2 into 1, means that is e raised to minus 0.2, and this value is 0.818. For n equal to 2, this signal amplitude is e raised to minus 0.4, and that equal to 0.67. Similarly, for n equal to 3, this signal is e raised to minus 0.6, and that equal to 0.5488. Now sketch this discrete time signal or the sequence for the different n 0, 1, 2, 3. We can also find out the amplitude for 4, 5. For simplicity, we have considered only this n equal to 0 to 3. This is x of t. For 0, the amplitude is 1. For 1, the amplitude is 8.18. 8.18. For 2, for n equal to 2, this is 0.67. 0.67. And for n equal to 3, this is 0.488. Now this the signal is discrete in time and continuous in amplitude, 0.818, 0.67, 0.45488. Then the periodic signals and aperiodic signal, that is non-periodic signal. A signal which repeats itself after certain interval of time for infinite time is called as the periodic signal. And non-periodic signal which does not repeat itself after certain interval of time is called as the non-periodic signal. Second, this signal which satisfies this condition, this mathematical condition, is called as the periodic signal, where the smallest value of this t0 is known as the fundamental period of that signal. And for the discrete time signal, this is the condition for the periodic signal, for discrete signal, and the smallest value of n0 is known as the fundamental period for the discrete time signal. And for non-periodic signal, this condition is not satisfied, that is x of n, that is not equal to x of n plus n0, then that this sequence is called as the non-periodic sequence, or this signal is non-periodic signal. Now this is the graphical representation of the periodic signal. The signals is repeat after certain interval of time, and here the certain interval of time is the 2 pi, means this signal will repeat after 2 pi, 4 pi, 6 pi, like this. Means this 2 pi is called as the fundamental period. The smallest value is the fundamental period of that signal. And here this is the sequence, and the sequence will repeat after this n. Now this is the graphical representation of the non-periodic signal. The signal does not repeat, is called as the non-periodic signal, because the signal is exist from -1 to 1, and the signal will never repeat. Now find the fundamental period of the continuous time signal. Now we know this basic relation 2 pi f0, that equal to omega 0, and t0 that equal to 1 upon f0, means the time period is the reciprocal of frequency. Now here our interest is find out the fundamental period, means 2 pi this equal to omega 0 divided by f0. Hence what is t0? t0 2 pi divided by omega 0 that equal to t0, because 1 upon f0 is the t0, means using this equation we will find out the fundamental period of this signal. Now in first problem, x of t that equal to e raised to j 5t, here the omega 0 that equal to 5, because if we compare this equation with standard equation j omega 0 t, then omega 0 that equal to 5. Yes, what is t0? t0 equal to 2 pi divided by 5 second. The second example is x of t, second sine of 50 pi t. Here what is omega 0? Omega 0 is 50 pi. Sine omega 0 t, means omega 0 is 50 pi. Hence what is t0? t0 is 2 pi divided by 50 pi. This pi cancel out, and here this t0 means fundamental period is 1 upon 25 second. Now case 1. Now here we will consider the two signals x1t and x2t. The both signals are periodic signal, and the fundamental period for the first signal is t1 and the fundamental period for the second signal is t2. Now if we add these two signals x1t and x2t, we are getting the another signal, that is new signal, that is x of t. Now the x of t may be periodic or may not be periodic. Now we have to find out whether this x of t is periodic or not non-periodic. For that we will find out the ratio of this fundamental period of the t1 x1t and this ratio of the t1 and this t2, that is the fundamental period of this x2t. And if this ratio is the rational number, then this given signal is periodic signal, means 2 by 3 or 5 by 8, like this integer, this is integer. And if this is the irrational number, t1 by t2 is not rational number, that time this given signal x of t is non-periodic signal. Then once we know this is periodic or non-periodic, then if the signal is periodic, then we will find out this period for this x of t, and period of the x of t we will denote this is by t, and this period t is LCM of t1 and t2, means find out the LCM of t1 and t2, and the LCM of the t1 and t2 is nothing but the period of that x of t. Now we will solve this problem, check whether this CT signal is periodic or not. If the signal is periodic, then calculate the period. Now this signal x of t is consist of x1t plus x2t, x1t plus x2t. Now here for x1t we will consider the time period is t1, and for x2t the time period is t2. Then first find out the t1. First step is find out t1. Now we know that this t equal to a t1 first signal x1t that equal to 2 cos 10t. Now here what is omega 1? Omega 1 is 10. Then T1 that equal to 2 pi divided by omega 1 that equal to 2 pi divided by 10 means pi by 5. T1 is pi by 5. Then find out second, find out T2, and T2 signal is sine of 4t minus 1. Now here omega 2 that equal to 4, hence T2 that equal to 2 pi divided by 4 in that equal to pi by 2. Means T2 is pi by 2 and T1 is pi by 5. This is the time period for the first signal, time period for the second signal. Then we will find out whether the x of t is periodic or non-periodic. For that, we will find out the ratio of T1 by T2. T1 is pi by 5 and T2 is pi by 2 and T1 is pi by 5. Then find out this ratio means pi by 5 divided by pi by 2, pi by 5 into 2 by pi. This pi will cancel out and that equal to 2 pi by 2 by 5. Hence T1 by T2 that equal to 2 by 5. Now here this ratio is the rational number. Ratio is rational number. Hence this x of t resultant signal is the periodic signal. Now second step, find out the period. Next step, find out the period for this x of t, and period for the x of t is the LCM of T1 and T2. But here the T1 and T2 are not rational number or integer number. Hence we have to convert into integer number. Now we will convert this T1 and T2 into integer number and then we will find out the LCM. Now T1 that equal to pi by 5 and the T2 that equal to pi by 2. Now find out the common number of this T1 and T2. The common number is here this pi, and the LCM of this 5 and 2 is 10, means common number is pi by 10. Then here we will divide this T1 by this common number pi by 10 and this is simplify this. After simplifying this is 2. This is integer number. Then T2 is pi by 2 divided by pi by 10 and that equal to pi by 2 into 10 by pi. Pi will cancel out. This is 5. Now here this T1 and T2 are the these are the new T1 and T2. Then find out the LCM of this new T1 and T2. LCM is 10. Then the time period for the t equal to LCM multiplied by the common number, and the common number is pi by 10. Here this 10 will cancel out. Hence the time period of x of t is the pi. Then the assignment problem, find whether the following signals are periodic or non-periodic. If the signal is periodic, then calculate the period. Now the first problem, x of t that equal to cos of 100 pi t plus 4 cos of 200 pi t, and the second x of n, that equal to cos pi n by 2 plus 3 cos pi n by 4 plus pi by 3. Now in this lecture we studied the definition of the signals. Signals are defined as a function of one or more independent variable, typically carries some type of information. Then definition of the system. Systems are used to process the signal. Then we discussed the continuous time signal and the discrete time signal. Continuous time signals are the signals which are continuous in time as well as continuous in amplitude. Discrete time signals are discrete in time and continuous in amplitude, are called as the discrete time signal. Then we studied the periodic signal and the non-periodic signal. A signal which repeats itself after certain interval of time for infinite time is called as the periodic signal. And non-periodic signal which does not repeat itself after the certain interval is called as the non-periodic signal. Thank you. We stop here.